The second unit in our course further develops our study of speech sounds by examining how different languages use their inventory of sounds in a particular possible way, so that two languages can have all the same individual sounds and yet sound completely different. I think the first slides in this presentation, together with the readings, will guide you clearly through some preliminary ideas, so I will leave it to you to read them on your own. I will be back when I think you can benefit from some explicit explanations. Enjoy. Languages use the phonemes in their phonetic inventory to tell words apart. So for example, let's take the pair of English words moose and goose, a rough phonetic transcription of which would be this, here representing the long vowel with a diphthong. Now, there is no doubt that the words moose and goose mean different things. This is a moose and this is a goose. But where exactly does this difference come from? Since the words are phonetically identical, except for one sound, the difference in meaning must be related to this one sound difference. In other words, it is the initial consonant in these words, or g, that contribute the difference in meaning. If this is systematic in the language, and in English it is, we conclude that for the speakers of English, the sound is different from the sound g. They can affect the meaning of a word by themselves. Another way of saying this is that in English, is in phonological contrast with g, or that in English, and g are phonemes of the language. And notice that when we write phonemes or meaningful sound units, we use yet a different kind of bracket. We write phonemes between slashes. As for the words that we use as evidence, we say that moose and goose are minimal pairs, because they are exactly the same except for one phone, and g, and their meaning is different. It is very important to remember that for a pair of words to be minimal pair, and therefore to be evidence of a phonological contrast, both conditions have to be met. They should be identical except for one phone, and there needs to be a difference of meaning between them. And this is how we represent that the phonemes between slash brackets, which sound as represented by the corresponding phones in square brackets, are in phonological contrast, which is what the little wavy dash represents. Not all sounds of the phonetic inventory of a language are in phonological contrast. For example, take the words pin and spin. Here is a phonetic transcription. These words are almost identical. I want you to focus on the voiceless bilabial stop, p. In our phonetic transcription of spin, it appears as we have seen it before in the phonetics unit. In the phonetic transcription of pin, however, notice that there is an extra symbol, that little H-shape superscripted to the symbol of the sound p. This is a suprasegmental symbol that represents the difference in pronunciation of the p phoneme in both words. If you put two fingers in front of your mouth and pronounce pin and spin, you will notice that in the first case, pin, there is a puff of air at the p sound that is not present in the case of spin. This puff of air, called aspiration, is what the superscripted H-shape symbol means. So, while pin and spin have different meanings, this is a pin and this is to spin, and there is a clear phonetic difference between aspirated p and non-aspirated p, changing p for p, meaning aspirated p for non-aspirated p, does not change the meaning of the word. So, if I say pin instead of pin, you might think that I made a small mistake or even that I have a non-standard pronunciation, for example, because of my particular dialect of English. But crucially, in exchanging aspirated p for non-aspirated p, or the other way around in the case of spin, I am not changing the meaning of the word, even though I have changed its phonetic form. This is very different from what happened with the moose-goose situation, in which the one phonetic difference was contributing a difference in meaning. In the case of aspirated p and non-aspirated p, speakers overlook the differences between aspirated p, and non-aspirated p. We cannot then say that aspirated p and non-aspirated p are in phonological contrast in English, because exchanging one for the other does not cause a word to change its meaning. Moreover, the distribution of aspirated p and non-aspirated p is predictable from the environment. Take a look at the following data. We have pot with aspirated p and spot with non-aspirated p, pat and spat, peak and speak, each one with the first aspirated and the second non-aspirated. What can we deduce from this small set of data about the distribution of aspirated versus non-aspirated p in English? If we look at the context where aspirated p appears, that is, at the sounds that immediately precede or follow it, we see that it appears before a vowel and in a word initial position. Non-aspirated p also appears before a vowel, but never word initial and following an S sound. The important fact is that there are rules governing the distribution of these sounds. What determines their occurrence is not differences in meaning, but phonological context provided by the other sounds in the environment of these two particular phones. Of course, when we talk about rules, we still need to choose the best candidate for a plausible rule. In this case, the environment before vowel appears both in our generalization about aspirated p and in the one for non-aspirated p. So clearly, it is not a good candidate for distinguishing where to pronounce one or the other, since it is the same context. However, the fact that aspirated p always appears word initially and non-aspirated p does not is a better candidate for differentiating between them. It makes for a better rule, just because it includes all instances of one element, while at the same time excluding all instances of the other. In this case, we say that the phonemes aspirated p and non-aspirated p are in complementary distribution. Think of complementary distribution in terms of the world inhabited by the comic character Superman. Clark Kent is an ordinary man working as a journalist in a city newspaper, seemingly living a quite unremarkable life. However, when someone is in danger, he becomes Superman, the hero that keeps innocent people safe from evil forces. Clark Kent and Superman are the same person, really, but they are never found in the same environment. We always see him either as one or the other, depending on the circumstances. The same happens with Batman, the Incredible Hulk, and, you guess it, or not, with sounds like aspirated P and non-aspirated P. It is the context that determines the appearance of one or the other, because they are in complementary distribution. We say that the phones aspirated P and non-aspirated P are allophones of the phoneme P. And here is how we represent it. Here is the phone between slash brackets and the allophones in square brackets. To indicate that the phoneme appears as either one or the other allophone, we use arrows. And then we make a notation of the rules governing the distribution of one or the other. As we saw before, aspirated P appears word initially, while non-aspirated P appears elsewhere. Notice that we don't need to specify a rule for each allophone. When we have characterized the environment for one, we only need to remark that the other one appears in all other cases, whatever they are. This is like saying that Superman appears whenever there's someone in need, and elsewhere we find Clark Kent. We don't need to say that Clark Kent is in the journal office, in the kitchen fixing breakfast, watching TV, shaving, whatever. He's just there whenever he's not being Superman. He is the elsewhere allophone. Well, please grant me some license. Metaphors are never perfect. In any case, notice that the generalizations we derived from the data also allow for an alternative model, in which the phoneme is also realized as two different allophones, but non-aspirated P is the one determined by the context after S, while the aspirated P is elsewhere. And again, please familiarize yourself with the terminology. This is the phoneme, and these are the allophones of the phoneme. There is a third possibility of sound organization in a language. Sometimes two or more phones can occur in the same phonetic context without causing a change in meaning. In fact, whether one or the other appears seems to be completely random. For example, the word that appears in your screen can be pronounced as data or data, but this variation does not change its meaning. It is like that variation we saw at the beginning of the course between either and either. Normally contrasting sounds like a and a do not contrast in this word. The variation is a matter of personal preference. In this case, we see that a and a are phones in free or stylistic or dialectal variation in this context. So in sum, two sounds in an inventory can be in phonological contrast if they carry a change in meaning, or they can be allophones of the same phoneme if they are determined by the linguistic environment in which they appear, meaning the other sounds surrounding them or their location within the word. Or they can be in free or stylistic variation if they are a matter of speaker preference. In the following slides, I make a couple of points on linguistic variation. I want to show you that while we might find the same sounds in two or more languages, not two languages organize their sound inventories in the same way. I think they are self-containing, so I will once more let you read them on your own. So, you are now in possession of everything you need to start doing some phonological problem solving. Remember that the goal of these problems is to find out the relationship between two or more sounds from the phonetic inventory of a given language. And remember that in linguistics, we use the inductive method, which takes data as its point of departure. So you will need to start with a list of data concerning two or more sounds, alpha and beta. You will need the meanings too. The question will most often have the following shape. Are alpha and beta two different phonemes, a moose-goose situation? Two allophones of the same phoneme, a Clark Kent Superman situation? Or in free variation, in the language in question? So how do we go about solving this problem? The first step is to see if you can find minimal pairs involving alpha and beta. If you can, they contrast. This is a moose-goose situation. And your answer should be something like alpha and beta contrast, because there is a minimal pair, blah involving alpha and blah involving beta. Alpha and beta are two different phonemes. Remember, a minimal pair is formed by two words that are identical except for one phone, and they have different meanings. If you can't find minimal pairs, they are allophones, a Clark Kent Superman situation. And your answer should be alpha and beta are allophones of the same phoneme. Here, let's call it alpha. You might as well call it beta. We'll talk about that in the classroom. But this is how we represent it. Now the only thing that is left is to find a rule for one of the allophones and consider the other one the elsewhere allophone. If you can't find a minimal pair, but you find a pair that has a sound change but not meaning change, the sounds are in free variation. In this case, your answer should be alpha and beta are in free variation. And that's it. It's finished. And you should congratulate yourself because you are done with the problem. Now let's do some sample problems. For this though, I will need a blackboard. So let's move to the classroom. Remember, it is not as hard as it looks, and you can do it. Let's do a couple of problems together. Remember, the question will always be the same. You will be asked to compare two or more phones and determine whether they are two different phonemes, two allophones of the same phoneme, or in free variation. So let's start with Cindy. Here you have a nice little set of data. You will always have two columns. The first column is always the phonetic transcription. That's why you have the square brackets. And the second column is always the meaning. You will be basing your observations mostly on the phonetic transcription because we are talking about phones. But the meaning, of course, will be handy when you're determining whether there's a minimal pair or not. So in this problem, you are asked to compare three sounds. The bilabial, voiceless bilabial plosive, the aspirated voiceless bilabial plosive, and the voiced non-aspirated bilabial plosive. So all your observations will have to be about these phones, and you can ignore everything else. Remember, minimal pairs are pairs of words that have the same sounds except for one, and they have a difference in meaning. So here, if you look, for example, at number 1 and number 6, pano, which means leaf, and pano, which means hood of snake, whatever that is, that's a minimal pair because everything is the same except for one phone, and the meaning is different. So at least we know that this one, the voiceless bilabial, non-aspirated voiceless bilabial, and the aspirated voiceless bilabial are in contrast. And we indicate it with this curly little line. Now, look at number 1 and number 10. Pano versus bano. Pano means leaf, and bano means forest. They are identical except for one phone, and there is a change of meaning. So pano, number 1, and bano, number 10, are also minimal pairs. So at least we know that this one is in contrast with this one. Do we have evidence of this one being in contrast with this one? Well, yes, because number 6 and number 10 are also minimal pairs. Number 6 is pano, hood of snake, and number 10 is bano, forest. identical except for one phone, and difference in meaning. They are minimal pairs. What was it? So here is your answer. More concretely, your answer should be they contrast because there's a minimal pair, number 1 and 6, number 1 and 10, number 6 and 10, number 10 and 1, etc. So you can cite any minimal pairs that you need, and they are in phonological contrast. And that's your answer. Now let's do Italian. Here. Remember, the first column is the phonetic transcription, and the second column is the meaning. And remember, the question will be the same. Compare two or more phones and determine whether they are phonemes, two separate phonemes, whether they are allophones of the same phoneme, or whether they are in free variation. Here you're going to be asked to compare the alveolar nasal with the velar nasal. So, the first thing that you do is, are there any minimal pairs? And remember, minimal pairs are words that are identical except for one phone, and they have a different meaning. So yes, if you look attentively, 7 and 8 is a minimal pair. Tingo, I die, versus tengo, I keep. They're identical except for the vowel, the first vowel, and they mean different things. Now they are minimal pairs, so what they are saying is that E and E contrast in Italian. But of course that's not what you were asked. You were asked to say whether you had minimal pairs concerning the alveolar nasal and the velar nasal. So you have to look for minimal pairs that are pertinent to the question. Well, you can find out many things about the language. That's not going to help you with your main question. Okay? The same with fungo versus fango. You know, the same. You have a contrast in vowels, but that's not what you're looking for. So, are there any minimal pairs concerning the alveolar nasal and the velar nasal? No, there aren't any. So what do you do? So now you know that these two phones are not in phonological contrast, but that they are two allophones of the same phoneme. And remember, we write it like this. Here is my phoneme and my two allophones. My alveolar allophone and my velar allophone. And for the phoneme, it really doesn't matter which one you put. I'm going to put the alveolar one just because it's more familiar to you. Now, if there are two allophones of the same phoneme, they are in complementary distribution, and it's up to you to find out what that distribution is. So this is how we go about finding out what the distribution of these sounds is. I'm going to put in this column all the instances in which I have this sound, and I'm going to put in this column all the instances in which I have this sound. For example, number 1, tinta, would be here, because this is my alveolar in my alveolar column. Now, number 7 will be here, tingo, because I have here my velar. And I go on with all the other words. Now I have my data nicely ordered, so I can start finding out what the linguistic environment for the one sound or the other is. In order to do that, I have to list everything that appears before my sound and everything that follows my sound. So I go one word at a time, and I just list here everything that goes before it. So here I have, in tinta, I have this sound, in tenda, I have this sound, in danza, I have this sound, in nero, I have nothing, but silence is actually a very important phonetic non-sound. So I'm going to include it here, and I'm going to symbolize it with just the pound sign. Here I have the same sound as I had before, and here I just have my last sound. So this is everything that can happen in Italian in my data before my alveolar nasal. Now, what happens after my alveolar nasal? So I do the same. I go word by word, and I list everything that goes after it. Here, here, here. Here I already have it, and here I already have it. So this is everything that can happen after my alveolar nasal in my data. I do the same with my velar nasal. Everything that goes after it, goes before it, I put it in my little scheme. Bianca, or I could put the diphthong, but I'm just going to put the vowel. This one I already have, and this one I already have. So all these sounds can appear before my velar nasal in my data. Now, after my velar, I have the velar, the voice velar, plosive, and the voiceless velar plosive, and again the voice one, which I already have. Now I have listed here all the linguistic environments in which these sounds appear. It is time to find a generalization. So a good rule will not only be based on the data that I have and on the generalizations that I could draw, but will also include all of the instances of one allophone and exclude all of the instances of the other allophone. So in order to find it, I just look at first the preceding sounds of my two allophones, and I try to find whether there is no overlapping. If there is overlapping, I will never find a good rule, because I will never be able to differentiate whether it appears with one allophone or with the other allophone. Now, there's quite a bit of overlapping between my alveolar and my velar nasals here, so I know that the preceding sound will not be very indicative of the linguistic environment in which these sounds appear. Now, let's look at the sound that follows the allophone. In the case of the alveolar, I have t, d, s, e. And in my velar, I have g, k. So there is no overlap. So it looks like, for this set of data, the sound that follows the allophone will be much more indicative of which allophone appears. So I can already do that. I can already say that the one that is relevant is the one that follows, not the one that precedes. Right? So what we have here is like I have velar consonants in the case of my velar nasal that follow it. And I have, well, everything by velar nasals. Actually, I don't need two rules, remember. I can just say that this one is the elsewhere allophone, and this one will be the allophone that appears whenever there is a velar consonant appear. So now I have my phoneme, my two allophones, my rule including all of the instances of one of the allophones and excluding all of the instances of the other allophone, and my elsewhere allophone. And I'm done with the problem. One more thing. In order to understand the rationale behind some of the distribution rules we will discover, it is important to have an understanding of natural classes. A natural class is a group of sounds in a language that share one or more articulatory property, to the exclusion of all other sounds in that language. That is, in order for a group of sounds to be a natural class, it must include all of the sounds that share a particular property or set of properties and not include any sounds that don't. Let me give you an example. Look at the symbols that now appear in your screen. It should be clear that they are the natural class of voiceless stops. This is the natural class of voiced stops. And this is the natural class of bilabial stops. Now think for a moment, which natural class form the vocalic sounds that are now written in your screen? I hope you guessed that they are front vowels. The reason why natural classes are important is that natural classes of sounds tend to behave in the same way with respect to phonological processes. And this is going to be very useful when we are trying to find out what the rules of our allophonic variation are in our data. I am including an example of one important phonological process that you should have read about in the book, assimilation, in the following couple of slides. After that, I just list some other phonological processes also explained in the book. Please read the relevant pages. And that's it for phonology. You should now be ready to tackle the problems we have set for you online. I hope you have some fun.